Hi, this is Mrs. Boykin, and today's lesson is on adding and subtracting radicals, and later in this video I also have a segment on multiplying radicals. So if you're comfortable with adding and subtracting, feel free to skip forward in the video, but I'm going to work out a few problems. Basically, the premise for adding and subtracting radicals is along the lines of adding and subtracting like terms. So let's take a look at that concept. If I have 2x minus 5x, they're x and x. They're like terms, so I can combine the 2 with a negative 5 and I can get a negative 3x. If I have something like 4x squared plus 2x, now these are not like terms, so I wouldn't be able to combine them and I would just have to leave them be. So think of it along the lines of combining like terms and we should be good to go. So let's take a look at our first problem. Our first problem, we're going to start out by simplifying. You must simplify all your radicals. Okay, so our first one, we're going to bring out that negative 2 and we're going to think about what are the numbers I can multiply together to get 27, hoping that one of them is a perfect square. So I'm thinking of 9 times 3. And the square root of 9 is 3. So I'm going to bring that out along with my 2. They're going to get multiplied together because, again, the square root of 9 is 3. What's left is square root of 3 on the inside. Let's continue to wrap this up. A negative 2 times 3 is a negative 6 square root of 3. And we've taken care of our first. Let's take a look at the next one. Get that little eraser mark. And now we're going to be looking at a negative 2 square root of 45. I meant to change my color. There we go. So negative 2, and let's talk about what two numbers multiply together to get 45. Well, that's 9 times 5. And the square root of 9, we already talked about, is 3. 5, we can't take the square root. It's not a perfect square. We're going to leave it be. And now a negative 2 times 3 is a negative 6 square root of 5. My next radical up here, make sure I know what my sign is a negative square root of 3. Square root of 3 is already simplified, so we're just going to write it down. And my last one is minus square root of 20. So what can we multiply? We can say 20 is the square root of 4 times 5. And what is the square root of 4? 2. So we're going to say a negative 2 square root of 5. Now at this point, I'm going to be looking at combining like radicals. So over here, I have the square root of 3. I have another square root of 3. So think of this as a negative 1 and a negative 6. That's going to make a negative 7 square root of 3. Your other one over here is my square root of 5 and another square root of 5. So what are the coefficients? A negative 6 combined with a negative 2. And that's going to make a negative 8 square root of 5. And that would be your total answer. We cannot combine the square root of 3 and the square root of 5. They're not like radicals. So we would have two terms as a result of our answer. Let's look at the next problem. Alright, just like before, let's break it down. 18 breaks down to 9 times 2. And 9 is a perfect square, so we have 3 times 3, because the square root of 9 is 3, square root of 2. 3 times 3 made my 9 square root of 2. And that is my first term here. My next term, negative 2 square root of 8. Negative 2, what can we break down 8 to be? 4 times 2. Square root of 4 is 2. Multiply it with this original negative 2. And we have square root of 2. Negative 2 times 2 is a negative 4 square root of 2. And that's my second. Let's take a look at the third one. Negative 3 square root of 18. 18 breaks down to 9 times 2 Square root of 9 is 3. So we have a negative 3 times 3 square root of 2. Negative 3 times 3 is a negative 9 square root of 2. That was this term. And my last 2 square root of 2, that cannot be broken down any further, so we're just going to bring this down, plus 2 square root of 2. All right, looking at all of these, I'm noticing that every single term is a square root of 2. So now I'm looking to add up my coefficients. 9, negative 4, negative 9, and a positive 2. Well, 9 and a negative 9 equals 0. They cancel each other out. So we have a negative 4 plus 2. That's going to leave me a negative 2 square root of 2. Again, I combined the coefficients to the square root of 2 because they were all like radicals. Hopefully by now you'll be a champ at this one. So we'll go a little more quickly on this one. This is a negative 3, and 45 is going to break down to 9 times 5. Square root of 9 is 3. Multiplied by my negative 3 is going to be negative 9 square root of 5. 24 breaks down to, well, we can say 6 times 4. 2 times 12. 12 is not a perfect square, but I think I'm going to go with that 6 times 4, or 4 times 6. Perfect square, so 2 times the 2 gives me a positive 4 square root of 6. My third term is a negative 3 square root of 20. And the square root of 20 I'm going to break down as 4 times 5. I know 2 times 10, but 2 and 10 are not perfect squares, so that's why I chose this. This square root of 4 is 2. Multiplying it by that negative 3 gives me the negative 6 square root of 5. And this one is a positive 2 square root of 20. Again, we know that breaks down to square root of 4 times 5. And the square root of 4 is 2 times the 2 is 4 square root of 5. As I mentioned, I'm a little faster, kind of skipping some steps, hoping that you get the concept there. So now we're looking to combine our like radicals. There's a square root of 5, another square root of 5, and a third square root of 5. This 4 square root of 6 is not like, so we're going to disregard that one for now. And we have a negative 9 and a negative 6. That makes for a negative 15, plus 4 is a negative 11 square root of 5. And then the other one that is not like is 4 square root of 6. And there is my completed answer. Okay. Again, if you have any questions on adding or subtracting, come on into Cav Morning and talk with your math teacher. Let's take a look at our next topic. This is where we get into multiplying radicals. So I want you to understand what's on the outside of a radical when we multiply is going to get, we're going to multiply it by whatever's on the outside. And what's on the inside the radical, or under the radical, the radicand, we're going to multiply those together. So out will get multiplied by out, and the result here. In will get multiplied by within, and the result goes here, and then any simplifying will take place. So easy concept there. Out times out, in times in, and simplify. So let's get rid of this so we can have room for our work. Alright, so we're taking a look at our first problem, and anytime we have something outside a set of parentheses, we know that's the distributive property. It's just no different than if I had 2 times 3 plus x. I know I've got to distribute my 2 to both terms through the use of multiplication. Same concept here, except for we have a radical. So 2 square root of 2 times 3. Now 3 doesn't have a radical, so he's considered out. The 2 in front is out, so 2 times 3 is 6. And there's no radical after that, so we just bring down the radical 2. It's like being multiplied by the square root of radical 1. It's invisible. Now we need to also distribute to my second term. So 2 square root of 2 times the square root of 2. Now we technically have a 1 outside, so 2 times 1 is 2. Keep in mind, what's under gets multiplied by what's under. So square root of 2 times the square root of 2, that's a square root of 4. Because what's under gets multiplied by what's under. 2 times 2 is 4. The square root of 4 is 2. And 2 times 2 is 4. And 6 square root of 2. We cannot combine these because they are not like radicals. So this would be my answer. Let's take a look at our next problem. A little similar. We have the square root of 6 times negative 3 square root of 2. So it's like a 1's on the outside. 1 times the negative 3 is a negative 3. What's under gets multiplied by what's under. 6 times 2 is 12. Let's go ahead and distribute to the next one before we simplify that. So let me go ahead and erase some stuff here so we can get a clearer picture. And we're going to multiply, like I said, this square root of 6 times the positive 3. So this is a positive 3 square root of 6. Okay? So let's go ahead and simplify. I know 2 times 6 would make 12, but 12 can be broken down another way. It can be broken down as 4 times 3. And we want to do it that way because we have a perfect square here. So square root of 4 is 2. We're going to multiply it by the 3. So negative 3 times 2 is a negative 6 square root of 3. This is 2 times 3. We can't break that down and simplify it any, so we're just going to bring it down. And our final answer is negative 6 square root of 3 plus 3 square root of 6. Alright, the next two are a little bit tougher. So let's take a look at the next one. Here we have a binomial multiplied by a binomial. Basically, two terms being multiplied by two terms. So what we do here is I like to use the box method. So I'm splitting up my terms. Negative 2 and a positive square root of 5 times 1 times plus 4 square root of 5. Let's make our box. Kind of like our multiplication tables. I wish I knew how to draw straighter lines on this. And we're going to multiply and put the answers in the box. So negative 2 times 1 is a negative 2. 1, it's like a 1 out here. So 1 times 1 is 1 square root of 5. Really the 1 is not necessary, but if it makes you feel better. Here we have positive 4 square root of 5. So the positive 4 and the negative 2 get multiplied and you get a negative 8 square root of 5. Here we have 4, nothing on the outside but a 1, so that's 4, and square root of 5 times the square root of 5 is the square root of 25. Now, the square root of 25 can be simplified, that's 5. So 4 times 5 is 20. So 20 is what we're going to use. We're going to combine that with a negative 2 because we're going to now add like terms together. So 20 minus 2 is 18. We have 1 square root of 5 and a negative 8 square root of 5. So I guess having this positive 1 written there helps us to remember this is a positive 1 combined with a negative 8, making negative 7 square root of 5. Now don't multiply those because at this stage we're just combining like terms. So don't remultiply those radicals. We're combining like terms. We're just adding our like terms together. And this would be our answer. Last problem. This problem here is whatever's in the parentheses is being squared. So if we have 6 squared, we know that means 6 times 6. If we have x plus 2 squared, that means x plus 2 times x plus 2. We can write it either way. This is the preferred way. This is simplified. So what this basically is saying is we're taking what's inside the parentheses and multiplying by itself. So let's take a look. This would mean negative 2 square root of 5 plus square root of 2 times negative 2 square root of 5 plus square root of 2. What's inside the parentheses is being multiplied by itself. So let's pull this out and use our box method. And multiply. Negative 2 and a negative 2 make a positive 4. Square root of 5 times the square root of 5 is the square root of 25. Let's go ahead and simplify this. Square root of 25 is 5 times 4 is a positive 20. So we're going to remember that's what we're going to use. Positive square root of 2 times a negative 2 square root of 5, well, this is a positive 1 times a negative 2, and square root of 5 times the square root of 2. What's under the radical gets multiplied times what's under the radical, so 2 times 5 made square root of 10. Over here, negative 2 times 1 is a negative 2. Again, 5 times 2 is 10. And I can see I have like radicals now. And here we have square root of 2 times the square root of 2 is the square root of 4, which equals 2. So we're going to use that. Alright, so let's go ahead and combine like terms. I have my positive 20 and a positive 2, making for a positive 22. A negative 2 square root of 10 combined with another negative 2 square root of 10. Remember, combine like terms, we're just dealing with the coefficients. Negative 2 and a negative 2 make a negative 4 square root of 10. 10 cannot be further simplified, so this would be our answer. I hope you found today's video helpful. Remember to come to CAV Morning and talk with me if you need any extra help. Be glad to help you. Thank you for watching the video. Let's get to the homework.